should be placed in a systematic order of priority. This is where the most used are the most easily accessible and in a familiar location. There are two reasons for good organization. First, for example, if tools are scattered about, a pair of chain nose pliers of the miniature variety may be substituted in a task requiring pliers designed for a larger stronghold that cannot readily be found. Here, the misuse of a tool for a purpose that it is not suitable for may result in a broken pair of pliers. Another reason to organize tools is efficiency. Diamond setting requires the use of many small hand tools. One cannot conduct himself or herself in a professional manner if he or she is continuously searching for tools. Such a trade as diamond setting requires several tool changes each hour of the day. Eye loops offer close viewing for detail inspection of jewelry and diamonds. Some monocular loops are in the form of one or two lens mounted into a small tubular structure. A single lens that clips the side of eyeglasses is more accessible. For diamond setting purposes, a 10-power eye loop is recommended. Binocular loops, on the other hand, are acceptable for continuous viewing. These loops provide viewing for both eyes simultaneously, thereby offering dimensional viewing. Two types available are those attached to a headband and those that clip onto eyeglass frames. Ring clamps are used to hold rings and certain other jewelry for work. A common ring clamp is made from two pieces of hardwood clamped together with a swivel action between them. With a ring held at one end, a wood wedge is forced into the opposite end, causing the ring to be clamped tight. Another ring fixture is called a benchmate. This is a trademark name. It has unique features that allow the ring to be worked at multiple angles. It is sturdy, durable, and permits the diamond setter more freedom of movement.
To know the exact size of the stone rather than try and eye it. And so measuring devices such as the following are vital and must be in almost every workshop. These are various calipers used for measuring stones. The carat size indicates the weight of the stone, but doesn't give you any real clue as to the size, and especially the diameter involved. And so we use measurements such as this. Now this has different areas, such as 0 to 72 deuxiums. That's D-U-Z-I-E-U-M-S. There are 5.5 deuxiums to 1 millimeter. And this one happens to run from 0 to 120. Each line indicates dixiems, and there are 10 dixiems to a millimeter. So basically, this is a measuring device. The other end of it holds a stone, and this tells you the exact diameter of it. And just in case.
To engrave a circle, adjust dividers from the center point to the distance of the two arcs just made. It's obvious now that 2 radius arcs were made instead of 1 in order to accurately estimate a suitable distance between centers. Pivot the dividers steadily from the center point to engrave a circle around the center. The centers for each of the 6 surrounding diamonds will be found on this line. To find the center points, use a round graver to make a depression on the circle. Remember that 3 diamonds will be located along the finger line of the ring. This indentation will serve as the beginning from where others will be spaced. The 6 center points are engraved by dividers. Use the same adjustment found to engrave the circle. This should geometrically result in 6 equally spaced points. Begin by placing one point of the dividers securely in the indentation and engrave an arc across the circle with the other divider point. Continue to secure one point at that arc and engrave another further along the circle. Eventually, a point of the divider should cross the beginning indentation. Do not be satisfied until the spacing begins and ends at the same point. This is the end of the layout. Now the holes can be drilled. After the diamonds are secured, the excess metal between them and the beads is either removed or engraved. In this case, a number 1 high-speed ongulette graver was used as an option to make short, straight cuts from the diamonds to the basis of the beads. It's necessary for a flashy design that the cuts are made straight because later they will be bright cut to enhance the diamonds. The effect will be a series of engraved stars with no flat areas of metal remaining. A close-up view shows that the ongulette graver is directed from adjacent diamonds directly to a common point between the beads. This results in a series of uniform star-shaped designs. Notice that the metal is being cut by the sides of the graver. By beveling the metal this way, the flat surfaces can be eliminated. There will be many short, tedious strokes to make until the metal becomes planed. If the graver sticks into the metal, then lighten the pressure and try to shave it rather than using force. The process will take a while, but it's better to take time to avoid cutting beads off and distorting the intended design. Also, with all the excess metal removed, the beads will be easier to round off later and become more pronounced. In general, the objective at this time is to prepare the metal by forming engravings and reasonably smoothing all exposed surfaces. With that done, each section can be bright cut later with minimal effort. Next, use a cup burr to cap the prong tips. Here, a size 1.4 millimeter outside diameter is used. Maneuver the burr in the opposite direction of rotation and encircling the prongs as shown. With all the tips uniformly beaded, it will be easier to estimate and cut the bearings to a consistent depth. Also, since the prong tips are eventually capped anyway, it's better to do it now before the diamonds are set.
Brush the channel and check to see that no further filing is necessary. Smooth the bevels with a knife-edge pumice wheel. Use the wheel in a brushing manner with long strokes to avoid removing too much metal in one area. The pumice wheel should only be used enough to smooth the tiny bevels. Applying too much pressure will flatten the metal.